Hello, hello, thank you for joining in. Another stream on Bali Chaos. It's an open source project. You have a bunch of tools on the website, links on the front page. I changed the structure a bit, just trying it out. Let me first, before I dive into it, put my secondary display is the main display now, but something still open on my display that goes into the stream, which is not great. So we have this new tool on bikegears.com. I don't know why some pages are so large, like the logo is super. I'm also on a larger display, but yeah, I think it's to do with the amount of content on the page. Different browsers will scale this content in different ways. Also trying to make this selected by default so you can scroll using a mouse or finger, but I couldn't figure out how to turn that default. It's in this case it's a 30-second window. I don't know what this one does. This one you can select the specific region, which is great. And that one you can scroll. You can also scroll with the mouse in and out, which is good. And this one will reset the window size, but yeah, not an ideal control. You want something like a slider, something more user friendly. But at the moment I'll just leave that because I'm not even sure if we actually need it there. There's a mistake it's making here. So normal. Oh, and it's not scaling the right. It's also not scaling the y axis. Oh, no, it does. No, it doesn't. That's weird. You will test it a bit later, I think. Some occasions. So that I don't know why this line is not becoming thicker or something. Okay, and there's obviously, in this particular example, there's like a DC in the signal. Is this a real signal at all? I think it must be. It's about mouse pointer size. They seem to be all suspiciously the same. So I don't know if it's synthetic or recorded. I mean, yeah, there's some sort of noise. It could be noise overlaid on top of them. Yeah, you can see it here. You can see the green marking coming through the blue one, which is not great. But when you zoom in, it goes away. Yeah, about this distance, you can actually see it in there. I'm not sure if it's a problem or not. Anyway, we'll leave it as is for now. And also, so now also set it to open each tool in a separate in a new window. Well, this way we could also check which one we already tested so far. So I don't know if it's so let's see if we on the front page it is tested that. Yeah, that's the new tool, periodic. Why does it have a weird frequency domain? A PSD. So the y-axis here is power spectral density. Yes, should put units as well. This window here going on the, it's actually going up to 500. You can change linear or logarithmic. That's what the inverse frequency looks like. Anyway, yeah, this one doesn't look nice on the phone because all this need to be clustered or something. Don't know how to do it properly. You have them like on the phone. Yeah, it will look like this. Could at least move that window size bit elsewhere. So those controls are clustered more or less together. You have do you move this thing? Oh, come on. No, 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 no. I don't know if this is the right size for a phone. So why the group like this have to change all the ECG stuff in one place? And it's not great in terms of controlling all this. In terms of testing, doesn't do much. PSD G. Oh, okay. The middle as well. Yeah. So we have those two events executed in the beginning. It's pretty straightforward. I don't know if I need any comments on it or not. Probably not. Channel name. Yeah, that's fine. We need plot legend. Wait. We only have. I combine the plots on the mobile device or something. I don't know. Anyhow, go ahead. We have in the the other thing. I want to know how much. Right, so Firefox doesn't draw anything. Camera frames. What's right? It's the NI web service container that is drawing some CPU usage. Let's see what changes does it make. Well, it's under 1%, 0.2%, which is fine. Overview. So we had cross coherence. Signal integrity. Yeah, we can do more on that. We have spectral density in the new tool. Filtering. And now the CPU went quiet. And it's at 14% average amplitude. I have to change this list. Best AG. Yeah, this last one is a good one. I'll create like a fuzzy logic rule-based EG detector where you have control of the detector parameters. You want to essentially draw it on the screen, and then anything that corresponds to that drawing could be selected. Let's see, logic. But the idea is it's like a basic. And by the way, for most cases, you don't sort color. Again, different page. So I love this color. As you can imagine, that's the color of my website. We train it over here for the color. I like this one. It's yeah, like don't like black. Just saying it's not. I really love any shade of green. In the same way, no. Bad, bad, bad. It's okay. Yeah, that type of green, generally like all greens, but this type of green, yeah, it's not my favorite. It's like too bright. Yeah, this is great. And no, I don't like this one. Bad or indifferent. Yeah, yeah, bad, horrible. It's giving me the same things now. Right. So now, if I give it this one, okay, I don't know. Yeah, that's a good answer by a machine. I don't know. Please train me instead of ChatGPTs and the like, which that skewed towards giving you an answer in any type of situation. Which I like. Yeah, if that was a person, you wouldn't like it a lot. So now that gets my whatever, well, because I haven't trained it on it, can the other question is like, how does it extrapolate onto, say, if it's a color, if it's a similar color to one that I already trained it on, would it make a guess? So this one I would expect it to, yeah, that's about right. If not, awesome. So say if I wanted to correct it, yeah, and you could then see all the fuzzy logic thingy. Uh, Choose your opinion, learn, guess my opinion, verify the fuzzy, learn your opinion. Yes, for more training, more consistent training will increase intelligence faster. More consistent. It's consistent training here. So this one gives me oops, sorry, wrong. Bad. Yeah, it's pretty bad. It's horrible. Yeah, it's pretty horrible. So yeah, I don't think it gave me this shade, but if it's mm, yeah, haven't given me any red before. So in the same way, we give like an expert anything they are expert in and ask them to label. So it will, and I want to see everything, like all the parameters. I don't want any black boxes. It should show me how many times it was trained, intelligence level. I don't know. This would be 100, I guess, or something. 8 times trained. Then yeah, I wanna know what this consistency means. So if there's any inconsistency in training, you want a metric on that. Yeah, I want a metric of everything. I want to be able to save it. I also want to know what's its level of interpolation. So say if I gave it something different, close to this. Yeah, so I already gave it answers on this one. So yeah, I wonder what its thingy looks like. Then you should be uh, different. No, I pretty like it, but that's okay. Horrible. Pretty sure I trained it on red already. So yes, those are called FS files. We have one on parts in the tool that we have. Where's the fuzzy logic? Yeah, this one. So the parts FS will look like, let's open the tools. Well, first, let me save this one. Call it my favorite color. Rating. Okay. Um, pa, pa, pa. Yeah, I want to see its tools. Where is it? Advanced? No. Forgot. Fuzzy. MGI solutions. I don't know what that is. Security profile. No, that's max the measurement of the patient exploit and the device connect, which we do have. We can play with that, but I don't know how do you use it online. We could do something with it. Pa, 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 pa. Yeah, it's in control and simulation fuzzy system. Right. And then you can file open. So this is the parts one. This is what it looks like. Scalar. Its shape is pretty odd. I mean the shape. If you take upscaler and downscale this shape, yeah, so you have all the possible conditions. Part, right? You can see upscale, scale and downscale. Yeah, it's hard to test in here. The color one would be yeah, this one tells you which shape it is. So it's hard to explain. Well, that's why I need a tool like this. But even then, this is the color, right? Red, green, blue. So you have why is black? Range to 55, so it's that shade of yeah, it is. So it should interpolate, and you can edit it from here as well. So you can um oh, red, green. Do not like. It could be nice if you had an actual color, because this one combining two colors, right? Blue, green. So here there is a section. Yeah, this um, right. The colors the blue a lot much more some few. You have this ratings for each color, and then so say I want to confirm that the green about this region. Okay, you can see the color, the actual color in here as well. Right. So green in this region should be let's wait. If red some, green is much more, blue is few, then like that sounds right. 6. So first it should be extrapolating because it's from 0 to 255. So RGB value, and then you can test whatever you already trained. The opinion will be very high. As well. But you see, this gradation should be smoother because you don't want to be super dogmatic about it. And there's no training here. That's interesting. Yeah, that's what it means to be consistent in the training. So you shouldn't have like in here, you shouldn't have some sort of spike, a random spike, and you will have a random spike if you just well, if you train it with rubbish, you get rubbish out. But if it's indifferent, learn different, right? Yeah, correct. Yeah, it's pretty bad. Mm, right. So now, for example, I was about to mark this as indifferent, but before I already marked something similar with bad. So I should put. So if I want it to be consistent, then I should put bad again. I want to change this interface. The interface is very bad. Yeah, that's correct. So you can either adjust or just keep going. bad, horrible, yes, should be good, yes, bad, more like indifference, and I can um, essentially retrain. Horrible, no, it's not horrible. Horrible will be like blacks and super bright. Mm. Yeah, yeah, and like pinkish. Mm, yeah, it's not horrible, just bad. But leave it at that for now. Right, so now it's a. I was about to say it's answering most of. Yeah, so what previous was a mistake. I would have corrected it. It's pretty bad. Just retrain it. I don't know why it says that. So I might be getting some conflicting results. You want to be able to see it. You would be able to see it here. So let's save it again. Color rating. And we'll call it the numbers of time. It was trained. So training. Uh, 57 times. Times train. Let's open. Right, so this one, yeah, you get more. What? This just a cap on stuff that wasn't trained on. Not impressive. Don't remember that being an option. Like, honest, like, I don't know why these names are different to this tool. And oh no, no, this is interesting. If yeah, this I don't know how it's happening in something wrong. Something wrong before. What? Wrong. It's wrong. I never trained it on. What's yellow be red and whatever RGB it is. How do I? Yeah, it's yellow RGB. How did it come up with awesome? How did it come up with awesome? It's red and green. Red and green. Yeah. Ooh, so if I red and green both, it's through the roof. How come? If red is much and green is much more and blue is few, then really like. Well, first, really like doesn't sound like awesome. Oh, wait, the names are different for this thing. I mean, it is okay. Right. Should be cool. That's right. That's right. That's right. Bad. Okay. It's not surprising. Um, I don't know. The yellow stuff. How does it do this? Yes, and I get this conflicting like and really like goes up to 200. How's it like? It's 255. Hmm. Sort of area. I don't know how important this is. Like an RGB B color picker, color code. B is 0. Yeah, this less bright yellow is okay. This is actually looking like more like it. Just don't blue much more. So is it red? Some red, some green, and blue. Not impressive. Wait. Yeah. How do you watch it in 3D? Why? What the red, green? Look. Is it because it's conflicting? No, they both do not like. So that should be right. Yeah. How does it work? No, it's actually okay. Gee, it's weird. It was taking up CPU. I don't know why. It wasn't doing anything. Fix my screen as well. to answer that quickly. Sorry, don't actually try to make it about colors, but this is just an example of an interface that we could be replicating. Well, not horrible, just bad. Correct this. Yeah, it's pretty yeah, different will be a good description for it. Different. This one should be good. So why it's not already there. Let's train on 55 before we had 37. Looks pretty good already. It's answering most of things. And the good thing about it, instead of training it this way, could have just train it from here. So this is adjustable. We could change those like this. But I sometimes harder to do because you don't know what the results would be. Wait, previous one. That's pretty bad. Of what my color preference can tell about me. Surely there will be someone will be trying to label me with all sorts of things because of my color orientation. Was sorry different? Yeah, like some sort of shortcuts for this thing. But yeah, it's pretty good now. Yellow keeps coming up wrong. I don't know. Why is it wrong? To potentially have to try those. I don't know how much difference should expect in some cases for it to make a lot of difference. Yeah, before I was doing something funny, it wasn't. Yeah, like it's following. Yeah, so this is where you have the peaks, is what like combination that I like. In this case, green and red. Says I will like it a lot, and say if it had less green, more red, I don't like it. There's a and there's a valid there. I don't know why. of green and a lot of red. Some green, medium green, and a lot of red. But it's all pretty much. Ooh. Oh, because it's not labeled yet. Right. They want everything labeled like this. Question is center of area. Of sums. Max modifying a bit. Yeah, this one is more like more rounded. It's the default option. That doesn't seem to correct too many things. Now we add. Let's do another one. Yeah, it's pretty good already. So we'll save that. Call it color rating. Was it 60? 60 times trained, so it will have 60 data points in the training set. And when we load it in here, it shouldn't have this. You'd expect, was it red and green, for it not to have any. I'm not sure, but those not trained, like they don't have any data, or it's a missing data, or is it really disliked? Let's go all the way to 0. I don't think so, but let's have a look. Have a look. Have a look. Open 60 red and green. Yeah, it seems like still weird. Green. Yeah, this one. How do you make a decision if you have so many? Yeah, and some of them are contradictory, aren't they? They're given different weights. Oh, it's complicated. It doesn't have to be this complicated because essentially there is a contradicting training, because it says yeah, very similar conditions, and it has what's it, like 4 or 5 different rules being invoked. One condition, just not good. How about blue? Blue is view with some more The problem is it's really like a three-dimensional graph, right? So you have your, can it be like three? I don't understand. Could be like RGB, red, green, blue, the z-axis, and the like, no like encoded in colors. So essentially have a fourth dimension. But no, that's not how it's being displayed. I wonder if we can make it better. I don't know. I don't know if you can hear me okay. Just saying we're going over this fuzzy logic rules. I trained this thing 60 times. Every time you get a color, it would estimate what do you think about this color. So I would expect this to give me something, yeah, indifferent sounds about right. I don't know why when you click on this button it should give you the answer already without you pressing another button. Horrible. It's not horrible, but okay. We trained it 60 times. It's giving an answer most of the time. Sometimes it's not very accurate. I was just saying we could apply this. What we want to do is apply this on a different signal, on like EEG or ECG, and have different labels. Yeah, this is obviously subjective. It's my opinion of this color. It's my color orientation. One indifferent, yeah, it sounds pretty much. Yeah, sometimes it surprises me, like with yellows before it was giving me something like this. Yeah, it's okay. But then I think it's getting a bit confused with. Oop, I think I skipped one. Yeah, this is correct. Then, okay, give me yellow. Just a random number generator. And in here, you can see the training set of all the rules. We essentially have red, essentially little red, some more, much more, and then how much you like it or not. So you have all these different combinations. Then you have the rules. Sometimes you have contradictory stuff, like, and then you can select red and green and your preference, and it will invoke different rules. Problem is, if you have more than, like in this case, more than 4 or 5 rules invoked, and in this case they're all similar, so they're all negative, so that should be okay. So if you have a lot of red, a little green, and a lot of blue, we don't like that. And all the invoke rules, they have different weight. So the one on top is the higher weight, similar to neural networks, I guess. So the answer will be on a scale from 0 to 5 will be 1.5 or so. So that's okay, but sometimes you get a contradictory answers which we're trying to avoid. Yeah, and most of them we want stuff like that, like this, where you have one invoked rule. You don't want any situation where there's no invoked rules at all. That so we can check. So that case there, when it's 0, there's something. Oop. Yeah, so this case where you have a, yeah, so zero essentially means no opinion because there's no rules being invoked, so we haven't essentially trained it on this. And this is the one with a 60 times train. That means that some of these colors, there's no result, a situation which we want to avoid. Let's just check something. So this is only two-dimensional. You have green and red, and then your answer. Question is how blue is being taken into account. So if I do this right, there is an involved a rule. And she's sitting over there. I don't know why. Red, green, red, green, zero, some red. Yeah, because of blue. Changing there. It is changing. What's in the middle of 255? So those are RGB numbers in here. So they go all 0 to 255. By the way, let me know if you can hear me okay. Or if you have any questions, comments, anything you would like to see on binarychaos.com and it's not yet there, please do let me know. You can also set up a Zoom room if you want to go live. It's another option. We have done this before. Had a mixed success, but we're happy to try it again. Well, technical issues with microphones and the like. This is the, just sorry, jumping around this back to binarychaos.com. As you know, there's a bunch of tools on the front page. They're all accessible for free. No registration is required. The most recent one is this noise comparison tool. So you can select your uniform white, Gaussian, periodic, or inverse F. Select the noise amplitude, but it doesn't really matter because this waveform will just scale itself. You can add a sinusoid to it, so you can see and choose its frequency. So currently it's sitting at 6 hertz. You can choose anything else, and then you see it's can make it like 1 hertz, and it will overlay the whichever noise type you selected. That's weird. I don't see any signal in it at all. I don't know why. How much larger does it have to be? Seems like this noise amplitude. Yeah, 10 is the maximum anyway. So yeah, it should look like this. I don't know what's up with periodic. I don't know much about it. But say if your noise amplitude is 0.5 and your sine amplitude is 1, yes, you still expect to see it, less so with Gaussian noise, and even less so with inverse F. So that's the problem with it, is that you will have to yeah, because it's very similar to EG. By the way, yeah, it's going all the way to actually 500. It's a log scale. It will look like this, linear, like that. in log, which is a standard way of plotting it. Oops. You have it as you could, okay, I think now, I think now, I mean, you could filter it out and still get this the 19 hertz, 20 hertz signal out of this. So if you had a real EEG in there, you would expect to have a blip somewhere there of the different EEG bands. So for example, if you have this spectrum, oops, let's say you have this spectrum. So it's changing the screen size on both simultaneous. Okay, so the original question was about removing the inverse F noise, so noise like this from EEG signals. So in this case, say you have this, what's it, 12 hertz frequency. So it will look something like this, say. So how would you remove that noise? Well, anyway, just the quick answer, quick and dirty way of doing it will be just doing a bandpass. If you know what is it you're after. So normally for epilepsy research, we do a bandpass between about 0.5 hertz to around 30 hertz, sometimes 40. Then the question, yes, what's the features of the filter, essentially how aggressive or not it is? That would be a good question. Whole spectrum filters. Nice. Yeah, no, this filter. Well, right. So you could just use your standard filters. Do I need an option? Log, no log. Similar to that. Don't know. Let me know what you think. But the bottom line is, yeah, the trending doesn't do much. In this case, Windows size is the same, but why do they look so different? A bit there. Not much noisy signal, is it? Yeah, looks just, that's sampling rate. different sampling rate, don't we? Different sampling rate. That's super important, isn't it? Mass sampling rate for this thing, I forgot. I had those details somewhere. I think in the original. Right. This signal will have a much lower sampling rate. Okay, so quickly, the data is at this delta t, which is sampling frequency of 400. So let us make a few quick adjustments. First in IG2, this number there we'll change it to 1 over. And we'll call it sampling frequency beta. Save that. And we want the same sampling frequency in our current tool call. I'm all open, that's okay, I'll open it from here. Inverse F noise. So this API on the sampling frequency to be time. What's it? No. Here. And this thing, the sampling frequency is sampling info. Great. Right, so that's 10 seconds. So we want this to be a 400 and 10 seconds. Does it make sense to make it smaller? Let's see. 10 seconds. No, this one is 10 seconds as well. This window size goes all the way to 60. Down to 1. Default is 10. So and here make it 4,000. It doesn't give us anything. Why? Yeah, it doesn't work. The 400. Make it delta entry by increment 100 goes to nearest yes. Should be the number of minutes. Stem. Understand what the problem is. SF. Right. No, I do understand. The field we put it for and 4,000. It's that field that doesn't work. This thing or cut off I cut off order. Missing order. Lectureship, but requires more computation time during filter operation. Actually, I want those as variables. With 400 to make 200. Also wondering for this one if I just close it or stop it, would I be able, so when I run it, yeah, it's reset. And can I load? So that's the color rating 60 time trained, and that didn't work. Nice. Ah, so that timer didn't increase. That's odd. Pa, 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 pa. And we have that now. Its intelligence level is low. If we run it to give us, I don't know, which is fine. When we load, right? Yeah, that's just a mistake. Yeah, it should be, it should say 60. I actually like this one. This one should be bad. Other interesting thing is, does it keep giving you random stuff or ones that you haven't trained it on yet? Or is this just is this a random number, or this one is okay? Yeah, skip that video. It's okay, that's awesome. Mm, yeah, they have a problem. I would have improved that by giving you setting a specific spectrum for training. So, like, say, all shades of red, all shades of this or that. No, how is this indifferent? It's actually pretty good. Doing some sort of interpolation. This should be awesome. The other thing, you could have ones that you have like there is strong opinion about, and ones that don't really matter. Well, I guess that's what the indifferent is for. Yes, it's like neutral. This should be horrible. Yeah, horrible just sounds. Because in another case they used something else in that example, not a different one. Mm. And of course, the holy grail of this stuff would be recording EEG, and for looking at the color and try to determine what the trying to determine the answer. using EEG as well. I don't know. Someone must have done it already, but don't know how hard it will be. Specifically, I do believe it's a lot down to implementation of how the interface looks like. This one is pretty bad. Yeah, well, there was an error with this when loading. It should have said 60. Yeah, you can see the intelligence level is pretty high. Yeah, and then I would have added some other things. Yeah, essentially a lot to do with bias. I understand this is a random number, but then once you get to higher training level, there is you could have a tick box saying, "Show me, the ones that you don't yet know the answer to." Another thing, a third thing, would be determining what's the interpolation is like, because it seems like some of the colors that, to begin with, even when it was below 50% intelligence level, intelligence suggests it has an intellect, doesn't it? Are the two words related? I'm not a native English speaker. Let me know. But it seemed like with low intelligence level, it would have shown me colors that seemed to me already gave it an answer for. So I don't know what's up with that, and will be good to, yeah. It seems like it doesn't get yellow, right? But what do I know? In this stage of training, you just wanted to show you all the stuff that bias it towards the colors that so essentially it's pretty split training mode and testing mode. Have them two separate things. Yeah, I think most neural net it's called assistive learning tools to do that. Right. So this one, yeah, find it. And also, when you click this button, you want the answer to be there already, like your estimate. Why is this bad? It's actually pretty cool. Seems like I stuffed up the training with something told the bright yellows ones. Ah, okay, now I get it. So this indifferent intelligence level suggests that there's that much percentage of them, whatever that number would be good to see the actual number. It suggests that that's how much it doesn't know. So actually, it's like an absolute system where you do know what you don't know, which is good. Yeah, like this one. On the other hand, I'm pretty sure it could have already make prediction out of what I already gave it to. At this stage, I would like it to just give me like finish training. Right, like this. Anyway, we could fix this one or just start a new one, and then we want to we could do classification between say ECG, EMG, and EEG. Like EEG would be harder because it could have some EMG in it, so it could be EMG in ECG, which is fine. It's still EMG because it would be much higher amplitude. Just take a note of it. So how about the fuzzy logic? So we can do signal type or noise type, which we like the recent tool that we have. We need to determine which type of noise it is. It's periodic thing. Double check something. Looks like it's making mistakes. Okay. Should show me something. Tell me. Trying to tell me something. Numbers. Wait. Visible. What? Sitting at -13. The first one. Yes, that's okay. We don't need the sampling rate to be so high. We can get away with this. Should be half of that sampling rate, is it? Perfect. Let me know if you can hear me okay. Just doing two things in parallel as per usual. But let me know if you wanted to do something else. First was updating. So looking at this fake signal that looks like EG, just inverse noise. So you have this new tool that can show what it can show. Different types of noise. Uniform, Gaussian, periodic. I think this one is wrong there. I have to correct that. Is it 0.97? Where is it coming from? And inverse looks correct. Yeah, we wanted to do a few corrections with that. We don't actually need it to go all the way to 500 sampling rate of 1000. It can go up to 400 a sampling rate frequency, and then this will just display 200, like the Nyquist half. The other thing about that, just say now we have a signal to noise ratio of 2, 1 divided by 0.5, which is quite high, but in inverse f, if the sine frequency is 12, which is similar to, so this is real EEG, it's another tool. This is the Neurovista intracranial EEG. In this case, in real EEG, we see this 12 hertz peak. So this will be in your alpha band. And assuming we had something similar here, then how would you detect it? Well, first, it depends on the amplitude of this thing. What? Right. Right, so even if it's just above noise level, it's already visible in the power spectral density graph, essentially a frequency response. In here, you can't see it. Yeah, so you could just bandpass it, which essentially what this does. Well, when you break your EEG into delta, theta, alpha, beta, you can have the whole spectrum as well if you like. And this tool also allows you to select the filter order so you can be more aggressive in your filtering or less aggressive, so it's overlaid like that. And normally 5, like 3 to 10 filter order should be good enough. And then just take whatever band you want, and that's how you got rid of your what's called inverse F noise, which is essentially this shape. We did, however, the reason it looks different is mainly, well, first is this is not logarithmic scale, so we can add a log option here. Yeah, we want this little chart is quite a handy little tool. Oops. We can move things around or reset it or select a certain area. So you can use your mouse for moving around. So probably want this little tool, which is built into, it's called the Levy NXG thing. So we want it probably everywhere there. We can add it straight away. No, you didn't ask for it, but I can, I already did it, I think. Just wasn't published yet. What's this tool called? IEG Spectrum 16. Yeah, this one. Right, so we want the graph tools, probably on both of them, just have them everywhere because they're quite nice. We also, is this frequency going up to 50? It should be going right up to 200 because the sampling rate is so sampling rate is 400, so you'll have your Nyquist right there. Yes, you get more information in there. So that's nice. 50 is set in here that yeah, 50 and no auto scaling, which is can make it log. We have an option to make it logarithmic. Do we do that in the, yeah, can have it here. It will look like auto scale fit loosely should go. Oh, well, yeah, it's going up to that's the problem, is it? With log, because it's going up to 200, which is over there, but then because log scale is showing 1000. Is it that okay? I don't know, but let's reverse it back to what it was for a second, and we will scale. No, it's okay, and we'll have an, oh, what's that? Didn't change, did it? What? Like, I didn't change it. Be up to, yeah, so it's the original view. Let's add an option for log scale. We can just copy it from here. So we have this, yeah, this frequency scale. We can copy that. We can copy that. Copy that. Copy that. Bad joke, is it? Right, we want to add value. So this will be an event case. We want to activate it when frequency scale is changed. We need to in a while. So frequency scale is changing. That's, by the way, the API. If you don't like mine, you can create your own. It's on the same site, and you can pull. Oh, now it's broken. Can pull the data out and make your own user interface. How good is that? Just listen there. Yeah, that's the, oh, come on. That's the input of the API. And this is what you get on the output. So you get your full spectrum and the 4 different EEG bands. EEG. The raw signal. So that's your frequency response. And delta T should be up there. There is MSD. No, it's okay. Yeah, delta F is for your frequency response. Then you have EEG if it's delta T. What you get in here. So that's fine. Do want to get rid of all the play buttons. So you have to actually scroll yourself. I don't want the automatic play. I want you to actively do something. So I might eventually hide all the play buttons in all these tools. Um, so we have this frequency thing, and we also need to we also need this bit. Yeah. So before any when it's executed, we want to execute both one of those events, so we get data, and actually it's important. We want them to be in that order, so we can use an error output. So that first, yeah, because otherwise you have what's called it's called race condition, when it's not clear which event is executing first. We want to have this here as well, and this doesn't look right. This should be just frequency scale. Create reference. Let's created a new one. No good, no good, no good. Not what we want. Okay, is that their message? Curves should not point to a control. It's an unplaced item. Of course it is. We need to place it somewhere. We'll place it in here. BSD static control reference. What's the problem with that? Should not point to control unplaced items. Oh, BSD. BSD. Oh wait. This should refer to this spectrum create reference. There is no PSD. There's the spectrum. Right now it's executable. And let's just try it. Funny. Right. More like it. Should go. Yeah, up to 200. And we can auto scale. Scale fit loosely. Okay. We just wanted to go up to 200. And no auto scaling, so no auto scale. Oops. And this should be 200 fixed. And then it should work both in logarithmic scale and linear scale. Like this is default of. Oh, my CPU is going. Right. We need. Oh, this log. Not changing back. Why? It's bizarre. This is the scale. We have some logic problem. So first, the scale could be just okay, problems. That's what we are here for. Well, first, it's better than what we had before. So that's second. We potentially want to get rid of that play function, that auto scrolling business. Well, let me know if you have any questions. Can I put them in, pop them in the chat? Say my streaming thing is poor. Stream health poor. What? Should be awesome. Even if I say so myself. Yeah. Yeah, the YouTube analytics thing. I don't know if anyway, just ignore it for now. Ooh, been already streaming for almost 3 hours. Well, we did quite a bit, but we now have this wicked error. It looks better with the whole spectrum. You make it log. You make it log. Happens. Mistake. What? Why is this? There's a coercion dot. Yeah, that red dot means that this input, which is 0 and 1, go X scale linear logarithmic in mapping. That's the class of the object, or that's the property of this scale. So when you switch it, it probably just needs to just try something. Can we pop this right? Oh, that anywhere. When I say anywhere, is precisely here. Can also run it. Can I look at rid of this relevant case, and in here one no add frequency scale. Why there's two of them? Right. Now it's better. So we have this. You can switch to log. Can remove it. It's limiting it to 100 because otherwise it's default going to 1000 because it's log 10. And we can switch. That's awesome. So we fixed that. We don't need this, do we? Channel number. Actually, yeah, we don't need that. Save it, test it quickly. Test it quickly. Just 1 sec. So we were reducing how do we clean this? How do we clean this? This is pretty messy. Yeah, because in theory, this thing will be happening in parallel, or there will be a race condition, or they should be happening in parallel. Even to save this thing. We have this. Not actually using this Skyline, using the NIG WebSockets, HTTP, STD library. Not sure. I'm pretty sure we're not using any of the Skyline stuff because it's a third party and it's actually paid. Quite costly. We don't use that. Don't use anything costly. Oops. So we had always also have an option to turn on linear logarithmic frequency scale. That's kind of standard, so I don't know, don't mention it, don't have to mention it. Now in here, this one is still, right, it's still going up to 500. That's not necessary. And in this, so this is where we make the API. We turn this one down to 400. Still have the 10 seconds, which is defined by the number of samples there. We had to limit the filter specifications to be between up to 200. Oh, it just doesn't work well, obviously, because of Nyquist. And we actually want to be able to change this value there. So the order is currently it's 5 as the standard. That order has specified the number of increasing order improves the inverse F spectral shape, but requires more computation time during field. Okay. First order stage. If so, we need to specify that. Right, but we haven't. We changed this. That's okay. Few seconds to wait. Change to alt. What? Ah, that's interesting. Right. Didn't realize it was doing it. When you scale this window, it just puts numbers there and then it puts outputs. When you do this, it's actually putting the names on the icon itself. Question is, do we need milliseconds to wait? Why not just pop it in? Those are optional anyway. Another thing we have to remember to improve speed everywhere. We have to make sure all these values are single precision. They don't have to be double. in JSON file, it has to be specified here. I can't then reduce the number of decimal points like I can in LabVIEW. So just turn it single precision everywhere and you'll be good. Save that. Please comment on this content. Your comments will be greatly appreciated and it will help me create more content. Because I need to know what's your interest, what your interests are, so I can focus on that. At the moment I have 74 stakeholders. That's the number of subscribers on my YouTube channel. So I want you to come back and watch. So if you ask a question, if it's yes or no, I can do it straight away. If it's more complicated something, I can address it properly in the next live stream, and then eventually you will also see it on bionicchaos.com. Which is, by the way, partially monetized. So sorry if you see, and it should be a one ad, just minor, just to cover server electricity costs. Otherwise, it's not for profit. So please check out the YouTube channel, the other videos. Please subscribe as well. And I'll see you next time. I might just keep going until the monster wakes up. I might just do it quietly so it doesn't wake up. This one, we made the changes to check method URL, noise type, milliseconds to wait. Needs to be delay this and show method again, delay ms. Yeah, we don't like spaces in here. Publish the web service. So we publish as deployment completed successful. So it was deployed, and we can test that straight on the site. So this thing, okay, going up to 200. Mm, but we can check this again. Yeah, this is 200, is it? We can scale now. Make this 200. Okay. Okay. Right. It's 6 to this. It reverts to the 1000. Why? Like how YouTube making me compete with myself. Window. It will give, it will tell 10 more views than previous 29 days, which is fine. Yeah, what is it meant to? What am I meant to do with this information? Um, just share views compared with previous periods. Over time, this can help you spot high performance views. Anticipates this is not changing and determine when to upload new videos. Okay. This is interesting. Okay, that's better. They have watch time, so it tells me I'm 28% less than previous 28 days. Channel watch time compared with public. Okay. And same with the number of subscribers. So 24% less. Like, yeah. So meant to. Next thing it will be telling compared to our YouTubers. But yeah, hope not. Interesting enough, when I live stream, I get a lot of at the same time. You get a lot of views on your other videos, which is interesting. It's just 48 hours. And this thing again, I'm not sure entirely what I'm supposed to do with all this information. Yeah, but it is what it is. It's really distracting, this thing, that's for sure. And it's really unclear how you're supposed to use that stuff. I think it seems like my subscribers are flatlining their mounts. So please subscribe if you watch this. It should help a lot promoting the videos to more people. So we fixed that one, which just shows if it, yeah, probably if you touch this one, then go to up to 1000, which is not really what I want. How does it jumps from? Did you see that? Nice. Okay. Hey, go figure. Still doesn't look right at all. The thing is, if this noise should have um, some sort of way to keep refreshing it. Because click onto stuff for it to be refreshed, but yeah, can do it. Can do it later, or especially if someone asks for it. Is no, this is good in this case. You need a separate, because um, in here I just do it in the same. What? Just simplify this thing, and we can take it offline as well. Close that. Test it quickly. If it comes up with yeah, might just take it offline. So I'll see you next time. And that will be tomorrow. Bye.